Or not.
Hello, I am not Romain.
And I am not Chet.
And welcome to...
That's a good thing, actually.
That's what I think. Yeah. Welcome to a moving experience.
So we're going to talk about animations.
Why are we going to talk about animations? So one of the questions that people might
I know
ask,
why. That's because you cannot shut up about animations.
I'm going to talk about them because I enjoy
at work. It's always like
talking
animations,
about
animations. OK, now you can talk.
OK, so I'm going to talk about them because I enjoy talking about them. You're going to listen to them. Actually, I don't know why you're listening to them. You should listen about animations because I believe they help create more compelling applications. They make applications maybe more fun, but that's not the real reason why it's actually worth spending effort on.
They also justify your salary.
They do justify my salary, so I wish you would write more and more and require more feature requests in the Android platform, specifically around animations. Thank you. One of the most important reasons is to engage your user, to actually connect them to the application, make them feel good about it, give them a dynamic experience instead of just some random poorly written web page that they click through in some form that they hate. Give them an experience from your application that lets them remember your application, the experience itself, and the precious quality time that they spent with it on their device. In addition, it can help them understand what can be a very confusing user interface experience, especially for people like my mother. If you can use animations to help the user understand the transitions and changes that are actually happening in the application and on the screen, then it can be a very helpful way to not only engage them and keep them connected, but help them understand the flow of your application in the way that you want them to, right? Alert them in a way that they can see on the screen of information that they need to know about. Help them transition from state to state so they understand where they came from and how they got there so that they can stay connected to the different states in the application as you're going through them.
So first, we're going to get started, and we're going to talk about 4 principles that are behind all good animations. So the first one is keep your animations short. There is nothing more annoying than when you use an app and you push a button, maybe by mistake, and then something happens. And we are very impatient beings. Like something that feels like takes 10 years on screen actually might last for half a second or just a second. But when you didn't want that animation, it's going to be very, very painful. Actually, it happened to us in our previous session. I was a little too impatient because I had a slow animation on one of the slides, and I hit the arrow again. And that skipped to another animation right after that. So it can be very painful for the users, and it can be very painful for you as a developer because you'll have to see that animation over and over and over again. I like to justify our principles in that way. Like developers, like that's going to be painful for you. So make it good for you. It's going to be good for the users.
Good.
To give you an idea, when you use a view property animator on Android, we have a default duration that I think is set as, 300 milliseconds? Yep. So 300 milliseconds is a good duration for a lot of animations on a mobile device. It's pretty short. It's not too short that we won't have enough frames to see the entirety of the animation. And for most animation, it's not going to annoy the user.
So one of the dynamics here, actually, with a lot of this stuff, we don't have an answer. We can't say 300 milliseconds is the duration that you should use for all animations, because that answer would be stupid, because it really depends on the situation. If you're moving a view a very short distance, I would expect that animation to be far shorter. If it's something that you expect to be almost an atomic action, I would expect it to be almost immediate. But if you're moving a view, and it's a large, complex view, and you're moving it from one side of the screen on a large tablet device down to the other side of the screen, bottom corner, well, maybe that duration should be longer, right? Make the duration appropriate to the animation that's actually happening and no longer. A really good example of this is the window animation that we use on the platform. When you switch activities or when you launch activities, we have a scaling fading animation. Well, there's a lot of movement in that. If you're scaling out from 0 and you're fading in from 0 to all the way opaque, you need to make it long enough that it actually makes sense and it's not stuttery and discontinuous because it's trying to cover a lot of distance. But if we did a really long duration, you would end up waiting a long time for that smooth animation. It would be really annoying. So what we do instead is we start a really long animation most of the way through. I think it's like 80% of the way opaque and 80% of the way scaled out, and then we finish the animation. So you get the implication of a very great distance being covered, but we do it in a small enough duration that it's not annoying.
And what's very interesting is that the duration you choose will also depend very much on what kind of animation you're running. The best example of that is if you move something on screen. If it's a small button, you can use a very short animation. You can use a very long duration, and it will still feel pretty good. But if you move something that's really big and really large, and you have the same duration as with that small item, like that small button, it would feel longer because the object will feel heavier. You can try that yourself, like write an application and try to move a really big rectangle versus a small rectangle with the same duration and the same distance, and the feel will be very different as a user.
That's actually why Galileo did the experiment with the stone and the feather, because he was testing animation durations. Another important principle, we'll try to bring up a lot of classical science lessons for you in this talk, is to make your animations smooth. If you have a really complicated animation that does a lot of really cool stuff and then it stutters in the middle, your user will hate you. What you want is a smooth experience from start to finish. Now, sometimes it's not possible for you to get all the information that you need to create the animation without doing something like a layout that might be a little too expensive. Okay, 2 tips about that. Don't run layout during the animation. We'll bring this up later just to drive the point home. And the other is, go ahead and run that layout or do that expensive operation at the beginning before the animation starts. When it's done, get the information you need, and then start the animation. And do whatever you can to keep the animation running smooth and performant for the duration of the animation so that that experience is smooth to the user. Otherwise, your animation is going to get super annoying. They're going to notice the animation. They're going to notice it because it's bad.
So performance, and we've talked about performance in many other talks before, is very, very important to having smooth animations, but it's not just about performance. If you change animations, the way you're going to change the animations, like the curves, the acceleration curves you're going to use, will also be very important to keep the animation smooth. And I think we have an example later on where we have a bouncing button, and if you don't do the bouncing right, it will feel like the animation is stuttery. It's not a performance issue, it's just a timing issue. So be also very careful with how you time your animations together.
Here's another one with a beautiful organic picture behind it. Make them feel natural. Make the user not even notice the animation because it just feels like it needs to be there. This is the interaction that makes sense for the application, not just a whizzy animation that you thought looked cool at the time. The idea is to allow the user to interact with your application in a way that they enjoy and which feels very organic and natural to them, not which just feels cool to the developer that happened to write the whizzy animation. And finally, you should make your applications not arbitrary. One of my favorite examples was, it was some release of Linux.
Yeah, on Linux desktop, there was something called compies, or there are window managers. Like when you close the window, it's really cool. The window catches on fire and disappears in a burst of smoke. Yeah, don't do that. We could show you how to write the code to do that. Oh, also, there was this awesome application on Mac OS X. When you burn a CD, the window would smoke. Like there would be smoke coming out of the window, like you're burning the CD. It's really cool. Don't do it.
It's like really fun the first time, and
actually,
after that.
There's one situation where you can do it, is when you're on stage at a conference and you show cool stuff to people and then you tell them to not do that.
We'll try to do some of that today. Don't do what we're doing. Yes, so make them make sense. Give them a purpose. Show the user what's going on in the UI, indicate some important action to them, help them during transitions in the experience, whatever. There's a reason for the animation to be there. Make that be the reason and not because you thought it was cool. So let's see a couple of examples. So actually, someone was just in office hours a few minutes ago asking, hey, I have a quick question for you if you have time. What is the correct way to do a ListView animation?
Well, here's the answer.
So we wrote some quick code, and we developed some slides. So we thought we would show you what we think would be the correct way to do this, a correct way to do this. So the example here is we're going to swipe an item out. And as we swipe it, it's doing a fade. And you can see behind it, we've got a little backdrop there, and we've got some drop shadow there. And then when we let go, it moves the rest of the way off, or if you don't move it enough, it snaps back into place. So we've got the animation of the swipe. And then after the item is gone, if we swiped it out, then the rest of the items animate into place. Fairly common for people to want to do this. Fairly common for people to not understand how to do this. So the interesting part might be to see
how many of you
code
have
to it.
tried to do this? How many of you have failed to do it?
Come on, don't be shy.
Sorry about that. It's mostly our fault.
Okay.
So here's the answer.
So let's take a little bit, let's take a look at the code. This might get a little bogged down because, of course, there's a bunch of code in there. We have a callback of code on the slide, so calling out the important parts.
Is the font big enough for everybody? People in the back? Or they don't care? Okay.
They are.
One guy said yes, so you're
all right. All right, so here we are. We are in ListView removal animation. Actually, I want to take a look at the array adapter first. We create a stable array adapter because I don't want my items to move out from under me. I don't want the content to change. So we will subclass array adapter and return back static item IDs. That's important. The other thing that we do in this very simple subclass is we set a listener because I want to track the motion on each of the individual items as we're swiping out, because that's the indication that we want to remove them. So
the stable ID is a way for ListView to keep track of what data belongs to what row on screen. It works without it, but for this purpose, it's going to be a lot easier with stable IDs.
The background container is where we manage the graphics that are going to draw the background behind the item that's being swept away, as well as the drop shadow in front of that background to sort of give the sense of depth, the difference between the layer that you're swiping from and the background behind it. Now, I could have and did in the first version of this simply have a background for the list view itself, and then I ran some of the overdraw tools that we talked about in a previous session today. And I could see that, in fact, we're drawing the background, and then we're drawing all the list items. That's a complete waste of rendering time. All I really wanted was a background behind the item that was going away. So I did that. So we have some code in here, some initialization code that creates two drop shadows. This could also just be a single 9 patch that draws both the upper and the lower drop shadow in that space. When we're told to show the background, that trips a flag, and we say, OK, we're going to be drawing stuff here, call our drawing routine. And then we set up the area in the container where we're going to draw this information. On size change, we set information about the shadows. And then we override onDraw. And in onDraw, we translate the canvas where we need to. We draw the background color. We draw the drop shadows. We're done. OK, but all the animation logic is in ListView removal animation, which is here. I should point out, too, I'm going to be doing some DevBytes episodes on these, and we'll upload all of the projects for the code that you're going to see here today. So I'm going really quickly through the code. The code will eventually be available so that you can go through it with better quality time later. OK, so we have a bunch of cheeses. We add them to a list. We create our stable array adapter, and we set the adapter on the list. All straightforward stuff for ListView stuff. On touch listener, what we want to do is track the action as we're swiping, because we want a little bit of not animated behavior, but different drawing behavior. We want to turn it translucent as it swipes back and forth. But most importantly, when we lift our finger up, we want to determine whether it's going to snap back into place if we didn't drag it far enough, or whether it's going to snap off the screen. So we calculate how far it went before we let go, and then we either snap it back or snap it farther. If we're snapping it off the screen, then we're going to animate the rest of the way here. So we're going to get a view property animator, and we're going to animate the alpha to all the way transparent, and we're going to animate translation X, so slide it all the way off. And then when that animation is done, so with an end action, we're going to restore some values here, and then we're going to animate other views. And that's where all the magic happens. So on to our next example. No. OK, animate other views. There's a couple of techniques here, which you're going to see over and over again in these examples, as well as some other ones, where we get information before a layout happens. And then we set a pre-draw listener. Then we get the information from the views after the layout occurred. So we've already removed our item from the adapter, which means the layout is going to run and is going to reposition all the other views in the layout according to the change that just happened in the list view, right? Standard list view stuff. What we want to do before that layout happens, this is synchronous, right? We remove from the adapter, and then immediately we go in and we do two things. We get information about where each of those views is. So where are you in the current container? And then we're going to store that in a map here, and we'll retrieve it later. And we're also going to use a property that's new in Jelly Bean called transient state. We're going to say set has transient state true. This is an important indicator to ListView to not mess with the view's content until I set it to false again. This is a ref counted flag that we note, and next time we go in to do a recycling pass, we don't recycle the views that have this flag set on them. And the reason this is important for animating items in list views is it means that we're not going to change the content in views that you may be potentially moving around on the screen. If you don't set that flag, who knows what's going to happen? In particular, what's going to happen immediately, it's going to run layout, it's going to recycle everything, and it's going to repopulate it in whatever order it deemed necessary. And that's probably not the effect you're looking for. So set has transient state true to all of the views that are currently in the list view. We set an on pre-draw listener. Layout is magically going to run, because we're going to return back to the UI thread. And then before we draw the results of that layout pass, we're going to get a call to our on pre-draw function. In here, we're going to remove the pre-draw listener. We don't want to listen anymore. And then we're going to go in and find out where everything is now. This is where it used to be. This is the cached value that we had before. This is where each child is now. We're going to find out the difference. We're going to calculate the delta. We're going to set that as the translation y property. So we knew it came from here. We knew it's now there. We're going to back translate it to where it was before, and we're going to animate to 0. So all we're doing is back translating and then animating to 0 into the real position that that view occupies now. The only other thing that we need to do here is we need to animate the new view that's going to be coming in from the bottom or coming down from on top. We know where that new view is now. We just need to calculate where we want it to appear from, and then we slide that in along with everything else. When we're all done, we set the has transient state to false, and we're finished. One other note about transient state, view property animator actually sets this property automatically. So during a view property animation, your views are safe. They're not going to be recycled out from under you. The reason that we had to set it manually, even in addition to the view property animator, is we didn't want the views to change during the layout pass, which happens prior to the animation that we run. And that's it for that demo.
Was that clear? You got all that? We will give you the code.
I think I pretty much walked through this.
Yeah.
So there you go. It's like that.
New demo.
Easy. All right, activity animations. So here's another one that has become common. We have two things in the window in activity changes that are available to you. One is the standard activity animations that occur already. Right? You get fadey, scaly stuff, as activities launch, and they scale and fade into view. That's fine, and that's actually great for an activity launch. It's a nice, consistent approach to running any activity. But let's say you're running a sub-activity and you want to do something customized. We also offer the ability to customize window animations, but it's very constrained animations. We added to that recently so that you could do a scale and a crossfade from a thumbnail in Jelly Bean 4.2.
Yes, 4.1.
4.1. And that's great. But you still can't really customize that. You can do exactly that thumbnail scale, and you can't scale back to the thumbnail, for instance. So there's sort of hard limitations to what you can do with window animations. So the recommendation is?
So we have a trick for you. So this is an animation, and actually Hugo Barr, that you've seen at the keynote sitting right here, told us it would be really cool if we could do it, and why is it not possible to do it on Android? And we're like, well, of course we can. So we did it. Actually, Chet did it. So I'm going to tap on a picture, and we animate from that picture into a new activity. So this is not just a view that we put on top of the first activity. It's actually a new activity that's showing details, and we can go back and forth between the two. And let me slow down the animation for you so you see exactly what's happening. There's a drop shadow, we scale up the image, we fade the background, and we bring the text. And it's actually pretty easy to implement. The trick is the new activity is actually a transparent activity, and all the animations are view animations inside that transparent activity. So we're going to take a look at the code. It's going to be a little easier. Let's get rid of all that stuff. There we go. So we have two activities. We have activity animations. That's the main activity of the application. And we have picture details activity. And there's another interesting class called shadow layout. We'll take a look at that a little later. So the main activity doesn't do much. It sets a grid. We use a color matrix filter to make all the images be grayscale, because we also animate from grayscale to color when we scale up the image. Then we just set up our adapter, so that's not very interesting. The interesting part is what happens when you click on one of the thumbnails. So what we do is we're going to start the next activity, and we're going to add a lot of extras to the intent that we use to start the activity. So what we want to send to the new activity is the position on screen of the thumbnail. So to do this, on View, there's a method called getLocationOnScreen. You give it an array, and we're going to fill the array with the x and y position of that view in screen coordinates. So it's not in parent coordinates. It's different from getLeft and getTop. It's not in window coordinates. There's another method for that. It's in screen coordinates. We create our new activity, our new intent, sorry. We remember the orientation. We'll talk about that later. And then we store the width and the height of the thumbnail. We store the position on screen. We store the resource ID of the thumbnail, like what big image should we be showing, as well as the description. And finally, at the end, we call this method overwrite pending transitions. And by passing 0, 0, we tell the window manager that we do not want any window animation. We're going to take care of everything, and we're going to do our own view animations. So then we launch the picture details activity. And in onCreate, we just extract all the data we need from the bundle in the intent. And here's what happens when we run the animation. So we check the saved instance state. So if we have a saved instance state, that means there was a configuration change. And most of the time, it's going to be a rotation. In that case, we do not want to run the animation again. So we only run the animation when it's the first time we bring up the activity, so when the saved instance state is null. So we set a viewTree observer. And the viewTree observer will, we use an onPreDraw listener that will be invoked, because we're on the onCreate method, that callback will be invoked the first, like before we draw the first frame, but after the layout. So after all the items are positioned in the window. So they have their width, they have their height, and they have their position. First thing we do is we remove the listener because we don't need it anymore. And then we have our image view with the big version of the image. It's not the thumbnail anymore. We're in the new activity. And we do what we've done in the previous activity. We look up the location on screen of the image. So we know like where we came from the previous activity in the intent, and we know where we want to go. We also compute the scale factor. So what is the difference in size between the big version of the image and the small thumbnail? And finally, we start our animation. The animation itself is very simple. We have our image that's been laid out at its final size, so it's taking most of the space on screen. We change its position and its scale so that it matches exactly the position of the thumbnail in the previous activity. And remember, because we're a transparent activity, it will look like we're in the same activity. The text is a special case. We make it invisible. And then all we do is we animate the image view, and we tell it to scale back to its normal size, so 100% scale X and scale Y, and 0 for the translation. At the end of the animation, we just animate the text, but that's just for the nice effect. We have secondary animations, and we're going to talk about secondary animations a little later. But we fade in the black background. We turn the image from grayscale to colors, and we're going to show you how to do this. As you can see here, we're modifying a property called saturation on our own activity. So we've created a custom property. It's not a feature of View. It's not a feature of the UI toolkit. It's something we've built ourselves. And you're going to see, if you've never done that, it's extremely simple to create your own properties. And we'll also animate the shadow of the picture. We have this property called shadow depth on our shadow layout. And here is our custom property. So we need a set saturation method. We also have a get saturation method. And all we do is we change the saturation in our color matrix. We create a new filter, and we set that filter on the image. And you're automatically going to get that nice grayscale to color effect. One interesting trick here is that we override the finish method.
Specifically for the override pending transitions, because like we did on the way in, we don't want to run window animations and have them get in the way and be parallel to the things we're trying to do in our customized activity animations. So as soon as we're actually finishing, then we override pending transitions, window animations get out of the way, and we customize the return back to the main activity.
And we also trap the back key events. So when the back key is pressed by default, we're going to finish the activity. That's the default behavior of the toolkit. Here, we prevent it from doing that. What we want is we first want to run our animations. So we call run exit animation, which is very similar to the animation we saw for the enter animation. And at the end of the exit animation, we're going to execute this runnable that's just going to call the finish method. Do you want to show the shadow layout?
Sure, sure. So shadow layout is it's a very simple view group. I wanted the ability for a container to put shadows behind all of its children. It has one property, which is the depth, which gets animated over time as that thumbnail scales into the nice colorized large picture, version of the picture. And as that animates, it's going to animate its depth property. The depth property is then used to determine two things about the shadow. The opacity, so we're going to be animating alpha, as well as the offset. So we're basically going to draw a shadow that gets larger and more translucent as the image comes into place in its large version. We're going to set up the shadow itself here, some rendering details about creating a nice blurred shadow.
Yeah, we don't have much time to talk about it,
Okay.
but if you're interested in how to create a blurry shadow without using a 9 patch, you could be using a 9 patch. That's a great way of doing it. If you want to do it programmatically, you can refer to that piece of code here.
We set the shadow depth here. This is called by the animation. Then we invalidate when the depth has changed, so that we'll actually redraw this container, and then we override on draw, and which processes through all the children of this container. In this case, there's just one, and it draws the shadow appropriately. All right. This is callouts to the various details there. I think we went through enough details on how to make that work. Again, the slides and the code will be posted later for the real details. We also wanted to talk about some cartoon animation techniques. It turns out that there were some people back in the 20s and 30s in Disney who thought really hard about how to make engaging animations. And they had a couple of very important constraints that were important to them and are still important to us, which is there's a very little amount of time and a potentially complex scene on the screen, which the user has to understand. And so a lot of their principles that they developed these 12 principles of animation. And a lot of them focus around focusing the user's attention on exactly what they need them to understand, simplifying that action as much as possible, and indicating and exaggerating around that action so that they can get all the information to quickly understand the important information about exactly how Mickey was running on the screen.
So we're not going to talk about all the principles of cartoon animations because they don't all apply to UIs, and there's a lot of overlap between the different techniques. But we're going to show you a few of them, and we'll have demos showing you how to implement those in your applications. So the first one is squash and stretch. And remember, one of the principles of good animations is that your animation should feel natural. And this is one way of making your animations feel natural. Instead of just when you move something, instead of just moving the object, you can try to elongate the object, to squash it and stretch it pretty much, to give it this more natural feel. This is not quite what happens in real life, and I'm sure you've all seen cartoons where someone kicks in a soccer ball, and the soccer ball becomes an ellipse pretty much. And this is something that we can do very easily in our UIs.
Another important principle is timing, and this refers to a couple of different elements of timing. There's nonlinear timing, which is important for conveying natural motion. People and objects in our real world don't move linearly. You don't start at the speed that you're going to be traveling the entire time linearly and then stop immediately. Instead, you accelerate into a pace and decelerate out of it, in general, unless you hit a wall. The other element of timing that's important—
Or if you're really weird.
Unless you're really weird, or a robot. The other important element of timing is to choose timing that is appropriate to the action. We talked about short durations before, the animations being as short as they need to be. But there's other elements of duration as well. I think as Steve Martin said, the important thing here is timing. So let's take a look at a quick demo of squash and stretch and a little bit of code. So the idea here is you click the button, and we're going to bounce it off the bottom of the screen. We can slow that down so you can see what's actually happening. So there's a couple of things. The down animation is a little more subtle than you might have suspected at first. You can see it's actually elongating a little bit on the way down. It's very subtle, but you kind of pick up that change. And it gives the indication that this button is actually kind of a rubbery material that changes and is affected by gravity and is also affected by hitting the floor. Maybe not something you want to do in your UIs. I would not recommend it in general. But in some situations, adding a little bit of organic properties to an object is appropriate.
Actually, we'll have an example of an application on the Play Store, a pretty serious application that uses some of these animation techniques.
So actually, the code for this, it's basically the same details over and over. This is just a sequenced animation where we run it down. We run a reversing animation that squashes and stretches out, squashes and stretches back, and then it runs back up. And this is just pure application of property values holder, creating an object animator object that can animate multiple properties at the same time. We set specific interpolators to get an accelerated feel down, to get a deceleration feel as it squashes and stretches, and then the reverse behavior on the way back up. We stretch. I mean, it's just the same thing over and over again. Property values holder, object animator. They're your friend. We repeat the animation on the squash and the stretch. And we set the duration very carefully to sort of give the right feeling between all these different dynamics here. And then we create an animator set to run these different animations sequentially. Pretty straightforward. Moving on. Next principle. Anticipation. This was important for the animators to indicate what was about to happen.
Like, for instance, if I want to punch Chet, I will start by doing this.
And I might start by doing this. If Mickey is about to run, he wouldn't just start running. Instead, he would rear back and run. And this was an important indicator to the viewer that something was about to happen. A running action was about to happen. So when it actually happened, they would be clued into that exactly going on. Instead of he runs, he's off the screen immediately. They blinked in that instant, and they don't know where Mickey went, right? So anticipation can be used to help the user understand an action that is about to occur. So if we switch over to the demo. Oh, that's right. I was going to run this on the next one. OK, so we have this Anticip button. This is a custom button. There's a couple of different things going on here. One is the anticipation. As I click on it, it's rearing back, indicating that it's going to do that run to the other side of the screen. So when I release it, then it actually moves. And then when it hits the other side, it's going to do the other principle that we were going to talk about on the next slide.
So this is the source code for this demo. So before we run the animation, we need a way to be able to do that deformation on the button. It's actually very easy to do on, so we have our custom class right here. So we extend the button class. We have our small constructor. We just set a click listener. We also set a touch listener, because what we want to do is on the down event, we want to be able to start the anticipation. And on the up event, we want to run our click animation. So to do the skew, here we're going to do something that I said was not possible yesterday. And
he lied.
No, I was misguided. I misremembered. The draw method is not final. You can override it. But if you do, make sure you call the super.draw method.
In point of fact, it's the only way that you can do this effect on some widgets. Mm-hmm. You can do the skew effect on a text view by overriding onDraw, which is a safer thing to override. But you actually need to override draw for the button, because that's where some of the stuff happens that you need.
For instance, the background.
Right.
So the implementation is pretty simple. We have our canvas. We have a skew factor. That's what we're going to animate. And we just call the canvas.skew method. So you don't have much to do. The translation here is just so that we can do the skew in the right place. And then we call the super.draw method. Then when we run the click animation, let's see. No, we have the anticipation animation first. So on the down event, when you push the button, we want to start doing the anticipation. So this is where we run this animation. So we just skew to the left. It's a normal animation. And if you let go of the button and the animation is not over, we're going to finish this animation. We're going to cancel it and go back to the origin. And then when we let go, sorry, we're going to create the move animation. So we're going to translate the button. And at the same time, we want to do the overshoot at the end. So when we reach the end of the animation, we're going to skew to the left and skew to the right, back and forth. And the easiest way to do it is to use something called the overshoot interpolator. So if you look at the interpolation curves, a linear curve is just a straight line. We also have the accelerate and decelerate curves. They look like S's or like an F. And the overshoot looks like basically a bounce. So this wobble effect, there's nothing for you to do. All you do is you animate this QX. You set the overshoot interpolator on the animation, and that's what's going to happen. And finally, we use an animator set to sequence all those animations. So we're going to do the move. We're going to do the skew at the end when we run against the wall, and then we're going to run the wobble. We'll go to, sorry.
So next principle, which you also saw in that demo, is follow through and overlapping action. When the button hits the right-hand side, we want it to have this feeling that it actually is a more organic material. So when it hits that wall, it can't just stop immediately. Instead, part of it would carry on, right? When we hit a wall, then part of our body will not hit the wall all at the same time and not stop. Instead, it's going to wrap around the solid parts that did stop, right? So how can you indicate that with the button? Well, we actually continue the skew. So as soon as it stops on the right, the skew continues and goes past, indicating that it just, maybe it had a little too much for lunch, and it's going to carry on where the rest of the button stopped. And then once it gets to that final point, then it's going to wobble back to the end point. So we saw that demo. I think we're going to skip the live button demo. It was another thing about anticipation.
This one?
Instead, we're going to do nonlinear motion. We'll show the demo. This actually comes from code that I posted on my blog, Curved Animation in Android. So we'll post a dev bytes about this as well, but I'll save the code for the article for doing this. The idea here is that we want to be able to move things naturally on the screen. Just like timing shouldn't be linear, in general, motion shouldn't be linear either. There's a more natural feel to things settling into place, which is not moving in a direct line. It's moving like people and real things in the world move. So sometimes curved motion makes sense instead. And as I said, we'll skip that code for now. Let me talk a little bit about exaggeration. And that's another technique that the original animators used to help indicate what was going on. If you're going to have a big nose, make it a really big nose. Indicate that this is one honkin' schnoz, right? You want to make everything bigger than life to help the user understand things even clearer and more quickly than they would otherwise. And in animation, that can help as well to exaggerate behavior, to either make things sort of hyper-real or just hyper-accentuate what's going on to help them understand quickly what's happening. For this, we're going to run a demo. Again, I'm not going to go into the code on this because there's a lot of code. There's a lot of different pieces. We've actually seen all the different elements of this throughout the other little micro demos. We've got custom activity animations as we launch from this activity into the next one. So that's actually going into a sub-activity. We didn't use window animations. We used custom activity animations where we came in immediately with a white background and then animated the elements in that view. We have a couple of different things going on here. One is that the buttons actually popped in. So they sort of did an overshoot as they faded and popped onto the screen to give a feeling of engagement, some feeling of fun to the kid that they want to attract and engage in the application. They want to be very interactive. And then the text skews to give that anticipation feeling. Engagement is very important in monetization.
What's your number?
So that's the entire activity. Yep. We won't enter the credit card right now. But another one is just, you got the button there. Well, you know what? You really want the kid to start playing. So this is a little bit funny. Like, we're probably not all writing cartoon applications, and it may be easy to write this off. But we've actually seen cartoon effects in other applications, again, used for the idea of engagement, of being fun, of being attractive, and being enjoyable to use. So here's an application, the path application.
So in this application, look, there's my avatar right here. Focus on the little circle just under the avatar. So I'm going to start scrolling the list, and you can see there's this anticipation. It's stretching and stretching and stretching, and there's the wobble.
Yeah, so it stretches organically, right? Just like our button did when it squashed and stretched. And then it snapped down, and it didn't just snap into place. It did a wobble. So it's got this feeling that it's rubbery, it's organic, and even more so, it's fun.
The animation is pretty annoying, actually.
Doesn't it make you want to enter a credit card, though? It does me.
It makes me want to turn off the phone.
All right, some quick tips here. We've seen some of these along the way. It's worth calling them out.
Really quick.
Very quick tips in 1:32. Avoid layout. If you want to have smooth animations, don't run layout on every frame. We've seen people trying to do ListView animations with this approach. Sometimes that's the only way to accomplish it, but frankly, if you can't run the animation smoothly because it's doing too much work, such as laying out a really complex container, maybe an animation is not the right solution for that problem. Avoid layout. If you have to run layout to get the after positions that you're going to animate into, that's fine. Run layout, then run your animation. Make sure you don't run layout during the
Yeah, but it's pretty much guaranteed that if you run a layout on every frame, your animation will be stuttery. View True Observer, you saw it real briefly. If you don't know about this class, I really encourage you to take a look at it. It can be used to listen to global events in the view hierarchy. So you can get an event when we are about to draw a frame. You can get an event when we are about to lay out a frame. You can also know when the touch mode has changed. So if if you have a device with a keyboard, you'll be notified when the keyboard becomes active versus the touchscreen. There's global focus changes. A lot of very useful information come from the View Tree Observer, and we actually use it quite a bit internally.
And layers, this is more of a performance tip. If you have a complex view or complex view hierarchy that you want to animate, consider setting a hardware layer on it during the animation. Don't set a layer on something that is actually changing, because we're going to have to recreate that layer on every frame. But do set it on a complex view whose alpha that you want to animate or that you want to translate on the screen.
So if you want to know more, we gave a talk called Animation Rules at Devox in 2009. It's available online on parlez.com. Chet has an awesome series of dev bites on YouTube about animations. You can also check out The Illusion of Life is the book that we're referring to. It's a great book if you manage to carry it back home, because it's pretty big.
It's a coffee table book. It is the size of a coffee table.
I use it as a coffee table, actually. No, it's a fantastic book. It's very interesting. The part about the principle of animation is really short, but there's a great history of Disney and how they came up with all those fantastic cartoons. So check it out. Our websites, and we're out of time. So if you have questions for us, we'll be at the sandbox.
After the fireside chat.
After the fireside chat, yes, there's that. And before you exit the room, if you want to read the session, you can scan the QR codes by the doors. Thank you very much.
Thanks.